Alright, hey everyone, welcome to the Land Ranger. I know this is a video that everyone has been waiting for. Thank you for all the engagement. The first video was fantastic. I truly appreciate the engagement, and I am blown away by the amount of people that have just played this video and subscribed and shows interest in this topic. So I want everyone to remember that I am a network engineer by trade, so a lot of this I don't actually really know because I don't do telco engineering, but I find it very interesting and I enjoy it, and so I find it a challenge. So I will try to understand this as I go along. Some things I'll say incorrectly, and that's okay because we are all learning together. And yeah, so to kind of make the intro here short, this will be the last video for my PLTE topic, probably until maybe next month or so. I do plan to do 5G, so the initial video for this was 100% a proof of concept. I did LTE instead of 5G because with an iPhone on 5G, you have to have an IMS, which is basically SIP, or the UE will not register. So before we get into this too far, the next couple of videos that I do will be networking related strictly. I do plan to do things like CMTS with DOCSIS. I do plan to do more LACP or BGP and other things on my next few videos. I'm not going to be focusing on PLTE as much, but I do want to stress that I'm not completely done with this. I am going to implement 5G with SUCI, and that's of course the authentication mechanism that is used in 5G, which the iPhone requires in order for you to be able to do that, or to use 5G. So again, this is going to be a short video, the bare bones basic in order for you to get this operational in your home lab. There's not going to be a deep dive into everything, and I think that, I kind of done that in the very first video, so there are some things that, we will touch in here that we didn't in the original video, and I can show you some of the configuration, or at least the running configuration that I have that does work. Thank you. All right, so what you're looking at here is the topology of how this kind of works. I am no longer using VMware's ESXi because of the way that USB enumeration causes this to behave. So with ESXi, when you load the FPGA, it will essentially cause the USB to flap, and the host controller does not reattach fast enough for the E210 clone to effectively operate, so it never really works. So I took and I put Ubuntu on the host, so it's bare metal, and the topology that you're seeing, as I said in the first video and the second one, this has changed a lot. So the basic topology description that I can give you all is that this is on a Lenovo. It has an i5-7500T. It has 48 gigs of RAM. That question mark has changed, but it's the CPU that's the bottleneck, so don't worry too much about the hardware. You do need more than 4 cores, though. RAMs, not so much. I'm using, I think, maybe 10 gigs of RAM overall, which there's various other things that are running on this host, so as long as you have the cores to push this, then you don't have to worry too much. The basic sense of Open5GS is when you install Open5GS, it is essentially everything that you see inside of this box, all except for Ubuntu. It's your MME, it's your SCP, it's your NRF. The first video we had, I talked about the AMF and how it manages like UE registration, the AUSF, which handles UE credentials and authentication, and like the NRF and all those things. I'm not going to touch on that here. So as long as all these processes are running inside of your host, then everything will be fine. SCP is very important, so as long as you make sure that all these things are operational, then you shouldn't have any issues broadcasting your own LTE. Okay, so if you have followed the quick start guide or your first LTE guide, that is going to be in the description of this video. If you followed it, then you have already installed Open5GS and the srsenb, and if you want to check to see all the services that are running, you can run this command here, and it will give you an output of all the things that are necessary for this to operate and show you kind of where everything is at. So as long as you have the services running, like the MME, the SGW, the AMF, the SMF, everything that's running on the Quick Start Guide, or that it's listed in the Quick Start Guide, then you should be good to go for this part. Okay, so here is the eBay listing for the B210 clone. It, of course, has the AD9361. It's also got the Arctic 7 FPGA. I have included a GitHub, a Git. Hub link in the description of this video, which has the binaries necessary for the FPGA. The source is in here as well. I did not include instructions for that because then you wouldn't need the bin file. So if you know how to compile those, you're welcome to do that yourself. It is a project file, so you can just import that project and then you can make changes as you see fit. But the one that I have highlighted here is an operational one and it works just fine. I've also included a basic output of how you can test and make sure that it is finding your device. Okay, so for some software out there, you like SDR Angel or you know, something that you might be using besides PLTE for this device, it is strongly recommended that you run the UHD utility usrp probe so that it will initialize the B210 and load the FPGA on and make sure that it's operational. As long as you get an output here, then things are okay. If you don't get an output, things are not okay. So any troubleshooting with that, you're welcome to do, you know, maybe do an issue on the GitHub post or the GitHub repo, or comment in the video and let me know and we'll try and work through it. I'll be more than happy to help you with that. Now this is where things get kind of difficult. The LTE frequency band chart, this was last updated, of course, in June. This is what I use to kind of figure out, you know, what LTE bands that I could use or what I could potentially broadcast and set things to. SRSRAN only supports frequency division duplexing. So there's like any of the TDDs or anything like that, you're not going to be able to use. If it's FDD, you're going to be able to use it. So basically you've got two links, like one frequency band is essentially used for the downlink, and then you have, which is, you know, from a base station to a UE, and then a different frequency band is used for the uplink, which is the UL. The RAN itself will derive the uplink frequency from the DL. So if I use, for example, 5230, which is 751 megahertz, then the UL will automatically be derived as 782. So as long as your internal clock source is well equipped, then it will be able to maintain these frequencies just fine. Just for another point here, I wanted to maybe bring up one thing that interested me. The ears FCN kind of threw me off when I first seen it. I'm like, what does that mean? But essentially it's the absolute radio frequency channel number. And of course there is some math that you can do out there to kind of calculate that if you wanted to do that. I'm not going to touch that because I'm not great at math. Okay, so here is Simlessly. These folks are awesome. This is where I generated my eSIM. And I literally just copy and pasted the physical SIM cards from PySim on the first LTE, or your first LTE's wiki page. So my ICC ID, my MCC and MNC, and my IMSI are pretty much just everything's copy and paste. And their portal is fantastic. I'm actually going to be paying for Simlessly to try more UEs. So if you wanted to create your own SIM, you're going to need to create a configuration template. I've got one here using my home PLMN of 310.789, and of course that's in my topology. So as you can see here, of course that's the country code of the mobile network. You know, the MNC is kind of what tells the UE, you know, the network that it's going to be connecting to. So 789 is private. I didn't see anything on there. The IMSI, of course, is the unique subscriber information, and then everything else is for authentication. So The PLMN, I'm sure most of you have seen. As you can see, my IMSI is 310789. That will always be the first 6 digits of the IMSI will always have the first 6 digits as the PLMN. So if that doesn't match, you will not have a UE attach. So to create a configuration, you'll go to Add Configuration, and they give you our very own private LTE. So I can just call this lanes LTE2. The SPN, of course, is your network name, so this will show up when you get the eSIM and in the top right next to your signal bars. So I just called mine lanes on both. And then, of course, you'll want to have your HPLMN, and then you can add restrictive networks, which would be OPLMN, or sorry, FPLMN, which is your forbidden network so that it doesn't connect to those. And O would be for roaming, which I do plan to touch on in the next videos. So I wanted to specify that on 5G with an iPhone, you have to have an SUCI profile. And that's one of the reasons I haven't spent too much time on the 5G yet. There's a little more involved. Another thing that you have to have on an iPhone is you also have to have IMS, which is essentially SIP, for VoIP. And if the phone doesn't have that, then the UE or the user equipment will not remain connected. So for just plain LTE as a proof of concept, and again, that's kind of what my other video was a proof of concept, you can leave this blank. If you accidentally click it, you can click the X to delete it. Once you create your template, you'll want to go to the fleet and generate an AC. I use simple generate, and then I literally just copy and pasted this stuff from the Your First LTE wiki into here. And as long as you have your configuration selected, then you can click generate. And here's my SIM card. So there was not a lot going on here, and I just scanned it with the iPhone's built-in, or iOS has a built-in eSIM tool that you can access from the cellular menu in the settings app. And I just scanned the QR code and off you go. I will say that it will have trouble activating. It literally will not activate. So if you put it on airplane mode and then wait until it says failed to activate or contact your carrier, and then you turn off airplane mode, as long as your radio is working, then you will receive and get connected. I'm not sure why it behaves that way, but that's how I've been able to get it working. It will fail, but don't freak out. As long as your RAN is running and your eNode is functioning right and everything else is right, then you will get connected after it fails. Inside the Open5GS config, the profile, account, and subscriber navigation buttons, there's nothing in the profile. You can add stuff here. I'm not 100% sure why you would do that in profile instead of subscriber unless that's for additional UEs. But the account is just for your administrator account. And of course, here's my IMSI. So everything in here is straight from the wiki page. So it's basically like what's in my SIM. So as long as your SIM is built exactly like this, then you paste the exact same information inside of Open5GS, and then you will connect. Service does need to be granted, and the session configurations like the ARP priority level, not to be confused with layer 2 ARPing. This is actually for QoS. I left all this default. I'm not doing IPv6 yet, but I am going to do that next. The only things that I changed in this profile for this subscriber is the K, the OPC, and the IMSI. Okay, so what you see here is a script that I built called run srsenb. I've made it executable. Basically what it is if you don't do this, then you have to run the binary specifying the ENB configuration in order for your ENB to start working. I didn't want to do that, so now I just have it to where it's just literally a single command. I've added this to my user local bin so I can run this from everywhere. So I can literally just do run srsenb and press enter, and now my FPGA firmware will be installed. And hey, we're broadcasting, so I actually probably have cell service. Yep, I sure do. Oh, and it connected. That's how fun. So yeah, it's ideally it's better to do that so that you can run it from anywhere, and it's a very simple bash script, and as long as you run your ENB or configure your ENB file correctly, then you can push that or pass that to that executable as well. Another command that I like to run is I like to tail for the log files. So if you want to view, because logs will save you, I just did a wildcard for any .log files and pressed enter. So now, if let me just test it actually. Oh, hey, look, our EMB is connected to the S1, and there's our device. Our UE is connected, and now I have service. So it's crucial that you review the log files because it's going to tell you when things are broken. I wouldn't worry too much about failed to connect to for SCPP or things like that. You're more concerned with MME. You're more concerned with the eNode, so anything with EMB, and you're more concerned with SCP as well. So SCP needs to function 100%, and so does S1AP. But as far as everything else goes, this is going to kind of help you troubleshoot things. You will see some errors in here that don't make any sense, but it's okay. They're not super crucial if everything is working. It's when things aren't working is when things become important to check. Okay, so here is our NAT rules. This is crucial as well for UEs to be able to reach the internet. Basically what we're saying is if it's coming in from any interface and not OGS ton and its source is 10.45.00/16, then we're going to NAT that behind whatever the WAN interface is. So as long as it's not OGS ton, which is actually where the UEs are at, then we're going to NAT it behind that WAN interface. So essentially, say my UE, which is my user equipment, is 10.45.0.2, it will, and my WAN interface is 192.168.6.2, then it's going to look to the upstream router like it's coming from 192.168.6.2. Your NAT rules do need to be configured. Okay, so if you have a problem with your clients, you could simply run this command here. This will restart all of the 5GS services and get everything back cleaned up and running. So I will put that in the description as well. It uses a wildcard for basically that says anything or Open5GS service or what have you. It will go ahead and restart those. Which is... Oh, okay. So what I changed in the MME config was that I changed it from a .02 to a .12 for the S1 AP. And that basically, I'm not sure why they wanted you to do that in the actual wiki entry, but I assume that that's because by default the application protocol was using that IP somewhere else. I don't know if that's 100% what it's for, but that's kind of where I was understanding everything to go. Now remember, the S1 AP is essentially the device that allows you, or the service that allows your UE, which is user equipment, to attach and detach from the network and other things like handover control and so on and so forth. So that is crucial. You need to change that. And of course, again, the article to do this is in the description. So you should be able to follow this and make progress with it. But for the time being, that's what I did. I don't remember 1.2. I think there was something that was using that. I don't remember why we changed that. It may be srsenb. But everything else in here, the only thing that I did change in here, and I probably should have added SRS or the RAN into the topology, but the only thing that I did change in here was the MCC and the MMC. That's 310 and 789 respectively. We also did that on the TAI. The security and other parameters or attributes are not needed at the moment. We're not doing 5G, so we can leave that alone at the moment. So we're actually, hope that'll, it's trying, but we have 5 bars right now, so And of course you see me connected there. You can always just Control-C and you can stop it. So this is the location where I compiled srSran, where I built it, and of course I've got my enb config, which you do need to modify. This enb, let me just do. You do need to modify this, so the MCC and the MNC needs to match, along with the address that we have created for the MME, which of course is now 1.2, whereas it used to be 1.100 or 1.1, but it needs to be accurate in order for the srSran to be able to communicate with the MME. So there's nothing else in here that I had to change. The rest of this is pretty default, but I did change the radio. So the DL is, of course, it's going to be your frequency range. And as you can see, if I open up, I'm on 5790. So 5790 is the center frequency of band 17. And of course, it's 740 and 710 respectively. So if I come over here and I run srs enb, we could see that it will use those respective DL and UL frequencies. It will derive the UL frequency automatically. So you don't need to set that because it's commented out. All right, that's basically it. There's not a whole lot to this. It just kind of is pretty straightforward. I've not had any issues. I think it would be interesting to see how 5G goes, because of course we're going to have to do IMS, and we're also going to have to do SUCI, and we probably will do that here in a few months, or maybe next month. I'll go ahead and start that. But yeah, if you're interested in some things, you know, like I said, my next video is going to be probably CMTS and DOCSIS. I'm buying some equipment to kind of set up my own cable network, and we'll probably end up doing BGP and some other cool things, and maybe some SBBM fabric, and probably going to touch more on 5G, like I said, in a little bit. There's some things that I want to take a break from with this because it was, you know, a lot of work, and I don't want to get burnt out on something because then I no longer find it interesting. So I want to learn more about this. So what I'm going to do is do a lot more research. That way I'm more or well equipped to be able to answer questions and answer them accurately. So I'm going to do some research, study up on it, and we'll touch more on this. We'll do some 5G. We'll also set a phone number on the SIM card so that I can make a phone call to another UE. And I also wanted to put up a terminology page, so definitions of things like UE and COTS and clip addresses, because you know, there's a lot of things that people probably don't know off the top of their heads. So if you're looking at the screen right now, you can see that these are some of the things that I've said in the video, and I hope it clears up some confusion. Anyway, thank you all for subscribing, for all the engagement. I've truly enjoyed commenting with a lot of you, and I hope to see you all continue to show engagement and continue to support the channel. Thank you so much. Have a blessed evening.